Okay, so here it is. Angle of elevation is defined to be an angle formed from the horizontal up. So, I'll have to show you how this works here. But angle of elevation would be measured from the horizontal. So like if I'm sighting to the top of the roof here, the angle of elevation would be from my eye level up toward that roof. That's the angle of elevation. Yeah. I can't. You have to take notes on paper. I only have one left. Let me say that for somebody who's absent. So angle of elevation formed from horizontal up. Angle of depression is the angle formed from the horizontal down. So that would be from my eye level down to the floor. So if we go outside and use my very handy-dandy clinometers here, high-tech clinometers, only the best for you guys. Are we going to be measuring angles of elevation or angles of depression if we're getting heights of, say, flagpoles and buildings and trees? Well, they'll all be elevation now. So here's an example of an angle of elevation problem. The Christmas vacation problem. So here's my dilemma. I go and I take my trusty axe here, or saw, hand saw. I'm going to go cut my own tree. I'm looking at this tree. I want to figure out approximately how high it is, but I'm going to have to pace it off, and I happen to have my clinometer with me. Go figure. So what I do is I measure, and it actually says I'm going to measure from the ground up, and I measure an angle to the top of the tree of 40 degrees. Now, in reality, most people, if they're doing surveying and using trigonometry to measure angles or measure heights of things indirectly, they're going to program into the device their eye height and not get on the ground and measure it. Okay? So if you have your eye height, if you know what that is, you're always going to just add, like my eye height is 5'8". I'm just going to add 5'8" to whatever I get after I solve my problem using trig, right? Because I'm already up 5 feet, about 8 inches or so. But we're just going to pretend he's going to go down to the ground, measure this angle of elevation. This is the angle of elevation of 40 degrees. He paces off the distance here and gets a distance of, what does it say in there?
12. No, that's 5. That's 15.
12 feet high.
Nope. Distance here, 15 feet.
Okay.
And the question is, what is the height x of this tree? Because my ceiling only goes up to 12 feet. So if the tree is bigger than that, then I'm going to have to leave it. Or think of an alternative, which most of us would do. So with this setup, which of the three trig ratios, sine, cosine, or tangent, would I use to solve for x?
You do cos.
A cosine would involve a hypotenuse. Have I been given the hypotenuse, or am I looking for the hypotenuse? So you can get rid of either one.
Figure out his angle. The
I
elevation.
told you I had a trusty clinometer with me. Don't you take your clinometer with you when you go cut down trees? So tangent is the correct setup. So I've got tangent of what? 40, yep. Equals what over what? It's going to be x over 15y. It's opposite over adjacent. TOA. T-O-A. Opposite over adjacent. So now how do I solve this for x? Let's multiply. Go ahead and do that. If you could tell me what you get for x. Approximately. We'll answer the question. So what is the height of this tree?
It's 15, 10 times 40 degrees.
15 times tangent of 40 degrees. That's correct. And what do you get?
Yeah.
That sounds a little high. About 12.5, 12.6 feet. Okay, so let's answer the question. Will the tree fit?
I don't think I know.
No.
Will the tree fit?
You have to cut down the base.
Okay, let's back up again here. Do you understand the setup?
Yeah.
Okay. Okay. Well, yours is probably different than mine. That's one of the challenges. So, I don't know what is yours a reverse order one? We haven't tried any on it. So, go ahead and type in. Yours maybe you have to type in the degree measure first, 40, and then tangent, and then do times 15.
So we're right.
So go ahead and hit 40 on yours, the angle first, and then hit tangent.
You're gonna have to cut off like part of the tree. That's not too bad though.
I want to hit it, and then it equals.
Oh whoa! He's riding a dragon. No, that's he's
40
riding
and then tangent.
an elephant. Like what?
Normal case.
He's riding what?
And then times. All right. Anybody else need help on your calculator? You got it? So we should have gotten about
12.5864.
Yeah. So the question is, will it fit?
Yeah.
No, not because my ceiling's only 12 feet tall.
No, you can just cut off and have
Yeah. That's where the practical part comes in. That's right. But would it fit as is?
No. And it would probably fit then because you'd have to
Okay.
stand it up and it'd be fitting.
Yeah, normally what we do is just go ahead and cut off the bottom.
Yeah, you probably don't want to cut like a
Or you can just run to the bottom. Just cut off the bottom, but as is, it won't fit. Okay. All right, let's look at our angle of depression problem. This is kind of depressing. It's kind of violent. That's the way we like it. So here's the deal. The sniper is up on a cliff that is 30 feet high. So here's a sniper. He's up on a cliff that is 30 feet high. We can just say, let's go down to here. Let's say the device for detecting snipers is maybe right there. Okay. So, well, actually, that's not going to work. Not with our cliff being 30 feet high. We're going to have to put the device down here at his feet. So it's in the toe of his boot. So the cliff is 30 feet high, meaning if the cliff is 30 feet high, then this distance over here is also 30 feet, right? And the angle of depression down to here is 24 degrees. So the question on that problem is, he's got this infrared device built into the toe of his boot, apparently. And we want to know what this distance x is, because this infrared device will detect the sniper if he is within a radius of 70 feet. So if you were to draw a big circle around, it goes off there, around here. This is the radius of that circle. This would have to go farther this way. So the radius of 70 feet, my drawing's not very good there, but I've got to find the hypotenuse, and I am given, from the perspective of the sniper, the opposite.
What is
The opposite. Huh? The circle is the radius, or this is the radius of the circle that will detect. It's the infrared device. It says it will detect anything within a 70-foot radius. So if this hypotenuse of this right triangle x is more than 70 feet, then the sniper's safe. If it's within 70 feet, less than 70 feet, then he's going to detect him there. Okay. And have somebody take him out from somewhere else. So here we go. Let's go ahead and set this up. I'm given the 30 feet is the opposite. The x is the hypotenuse. Which of our three involve O, opposite, and H, hypotenuse? Sine does, yeah. Hypothesis. So sine of 24 degrees equals opposite 30 over hypotenuse x. And I would like you to go ahead and solve that, please. Go ahead and solve for x. See if you find a value. Make sure it makes sense. If you need help, I can help you on your calculator.
Wait, why?
Yeah.
Okay, I'm right up here at the 24 degree angle. The 30 that's given is the opposite. Find what out?
It's 30.
I don't know what you're asking. I'm sorry. Our setup here is sine of 24 degrees is equal to the opposite over the hypotenuse.
30 equals sine of 45.
That's correct. It's 30 equals x times sine of 24 degrees. And then we have a little bit of algebra to do to solve for x. I divide each side by sine of 24 degrees. And so these cancel out, leaving me with x equals 30 divided by sine of 24 degrees. And so what do you get for x approximately? How do you do that in your calculator? Okay, in your calculator, you do 30 divided by 24 sine and then hit enter equals. On mine, it's 30 divided by sine of 24, and I get 73.7, about 74 feet. So can we answer the question?
73. Yeah, he's good.
So this is a sniper safe?
Yeah.
Well, he's safe because he's outside of that 70 feet. So yes, he is safe.
He has to take it.
Hooray.
Take a shot. Please, anyway. Why would he be there if he's trying to kill this guy?